All right, we're going to fill in 2 more sections in our flipbook because we just did 2 pages in our discovery packet. So go ahead and add your titles if you haven't done so already. Power to a power, remember to draw your title line, and product to a power, drawing in your title line. And we're going to cut both of those in half. So leave space for your rule at the top and cut those in half. Rule at the top, cut that in half. Before we get started, we're just going to review our checklist because our problems are getting a little longer. So remember, we need all positive exponents, no zero exponents. Okay, we have to get rid of all parentheses. If we have a fraction that appears, we need to reduce fractions. And each variable can only appear once. Numbers to a power must be simplified, so they actually have to be worked out. And then variables are going to start moving around a lot more than we have seen, so we have to make sure that they are written in alphabetical order. Okay, so let's move to power to a power. So in our worksheet, we said, our discovery worksheet, if I have some number to an exponent and all of that is to an exponent also, so power to a power, we can multiply those exponents. To simplify that. Now realize in our last video when we had powers of the same base and our bases were being multiplied together, we were adding. So a lot of people get these two confused, when we're adding and when we're multiplying. Okay, so some of you may want to start making little notes on the title pages of your flipbook so you know which one's which. So some of you might want to be, a power to a power, and just kind of write down an example of what it looks like so you can quick find it. I find this helpful. And so multiplying powers with the same base looks more like this. So we don't have to write the full rule, but maybe just write an example so I know where to flip to if I'm trying to look for help in my notes. Again, just an option. Most of you should know what zero and negative exponents are. We don't have to really write those out. And then why don't we write out just a quick example of product, 2 things being multiplied together to a power. Okay. So that's optional, but I find that helpful. On my old one from last year, you can see I've got all those kind of filled in. All right, back to power to a power. We've got a rule down. So let's try a couple practice problems. So power to a power says to multiply, so this becomes x to the power of 6. Same thing here, power to a power, we're multiplying, that becomes x to the power of 8. Now there's a couple ways to do this one because we see a negative exponent. So first thing I like to do is I like to multiply them because that just makes sense to me. But some of you may want to move all of this down first. And I'll show you either way it works. You get the same answer. So first if I multiply them, that becomes c to the negative 10th. And then I would have to move that negative down to the bottom because we can't have any negative exponents to make that my final simplified expression. The other way, if maybe you looked at the negative first and you're like, I have to move the negatives on this entire term, I have to move that down to the bottom. So if you did that, this would be your first step, like this, which to me just looks more complicated than this as my first step, but totally up to you. And then you would multiply them, which still gives you 1 over c to the 10th. So You don't have to write down both examples, just whichever one is kind of the way your brain thinks. But realize either way we get the same answer. So same thing on this next one. There's two ways to look at it. I multiply first, which gives me 0 times 7 is still 0. And then I know anything to the power of 0 is just 1. Okay, realize we also could have changed j to the power of 0 as being 1 first, all to the power of 7. 1 to the power of 7 is still just 1. So either way, same answer. The answer is 1, right? All right, let's look at a couple more complicated examples over here. All right, so go ahead and pause the video to give those three a try. All right, so in this one, there are a couple things going on. We have a power to a power, and we have like bases. So it does matter which one we do first here, because I can't combine my like bases here, because it's not just 1 and 3. I've got this extra exponent out here. So you actually have to do the power to a power first. So I need to multiply these. So this first k kind of just hangs out. I'm going to write a 1 to remind me there's a 1 on that k. Right? We don't write these 1s in, but we know it's there. And my power to a power makes this k to the negative 3rd power. So now I have same bases, multiplying exponents with the same base. So remember, that's our addition rule on that last page. So 1 and negative 3 make k to the 2nd power, and we can't, or sorry, negative 2nd power, we can't have negative exponents. So we need to bring that down to get rid of the negative exponent to get our fully simplified answer there. So this one, I've got 2 power to a power. So I'm going to multiply both of those to get r to the power of 20 times t to the power of negative 15. We can't have negative exponents, so that negative's got to come down. This comes r to the power of 20 over t to the power of 15. So I've got a couple a's, but before I can combine these this way, I've got my power to a power I'm going to get rid of. So this a to the 2nd power just kind of hangs out at first. Then it becomes b to the negative 18, because I got to multiply those two. And then becomes a to the power of 12. Got to multiply those. Now I can combine these two. It's all multiplication here. So multiplying powers with the same base, we are adding. So you see where it could get confusing whether you need to add or multiply. And realize 2 plus 14, or 2 plus 12 is 14. That I have a negative exponent here. I'm just going to kind of do 2 steps in one. I'm going to add those, and then I'm going to bring this down also. There we go. So that's power to a power. Let's flip to the next page to fill in our product to a power. So this was page 3 we did in our discovery worksheet. So the rule we found on that page was if I have 2 numbers multiplied together, let's just say a times b, all to one power, in parentheses, we can actually distribute that exponent to get a to the power of n times b to the power of n. All right, so let's do some examples. Go ahead and give those two a try. Alright, so the first two over here, this needs to become 8 squared times x squared. And then realize we can't leave a number to a power. So 8 squared I know is 64. So this becomes 64x squared. Next one, we got to distribute this 3 to each one of these. And again, that's multiplying. These all have little ones there. So this becomes 2 to the third power times x to the third power times y to the third power. And then again, 2 to the third power becomes 8. That's our fully simplified answer there. If you haven't tried these two yet, go ahead and pause your video, give them a try first before we go over them. So remember, there's a 1 there, there's a 1 there. So we got to distribute this 3. Distribute means multiplication. So this becomes 5 to the third power. This becomes x to the 6th power, y to the 3rd power. 5 to the 3rd power simplifies to be 125. And last one, this becomes 4 squared. I know some people want to do 4 times 2, but remember you're multiplying with that 1 there, not with the base, with the exponent. And then c to the 10th times, I didn't do anything with this other c to the negative 3rd power, but now I need to because I can't have a variable appear more than once. Okay, so I'm also going to square this 4 to make 16. And then, like bases being multiplied together, I need to add those, which makes c to the 7th power.